The first clause we'll be looking at is the partition by clause. The partition by clause is used to break the result set of the query into groups. So basically the partition clause does the following things. First, it splits or it breaks the result set into groups, and these groups could be defined by values in a column such as year or department in the case of our HR database. Secondly, it applies the function over each group independently. So if, for instance, you wanted to see the sum of salaries within each department, you would partition the results by the department, and then the sum function would be applied within each department. Well, you may be thinking now, is this not exactly the same thing that a group by aggregate function does? And yes, you're right. The partition by clause in analytic function is similar to the group by clause in the aggregate function, except that it provides much more functionality, and we are going to see that. The partition clause is optional, and if we have it, the function is applied over each group independently. But if we don't have a partition by clause, then the default group is the entire result set. So if we applied the sum function with the over keyword without a partition by clause, then the results will be the sum of all salaries for the entire company and not just salaries within each department. In our example here, we have used the over keyword without a partition. So by default, the sum function will be applied over all salaries in our database. So the result here is for each employee, you have that employee salary, but for a total, you have the total for all salaries in the database, and it is the same for all employees irrespective of their department. This is because we haven't applied any partitioning to this statement. So this is similar to a group by function where you can just say select sum of salary from employees, and you didn't pass a group by function. By default, the sum of all salaries in that table are returned to you. But if you group by department ID, then you're going to have the sum of all salaries within each department. But if we wanted to see the results with the sum within each department, then we would partition by the department ID. So if you look at Jennifer, who belongs to department 10, the total salary for that department is 4,400. And that's because Jennifer is the only one in that department. But if you go to department 20, then the sum becomes 19,000, which is the sum of all the salaries for employees within that department. And that is 13 plus 6, which is 19. So Michael and Pat have the same total here because they belong to the same department. And as you go down to 30, the sum for each of these employees again is the sum for all salaries in that department. So this is the power of the partition by clause that is passed inside the over keyword. Once you have a partition and you specify a partition field, Oracle applies a sum function or whatever function that you called here within each department and returns a separate sum for each department. One other thing that's very interesting here is if you look at the results of these partitions, you can see that we're able to display the salary for each individual employee alongside the aggregated salary for each department. This is one of the things that differentiate a regular group by function and an analytic function. In a group by function, once you've called a group by and you're grouping by department ID, there is no way you can display the results of these individual employees alongside the aggregated results, except you are using other joins and other sophisticated native SQL to achieve this. But as you use the group by function, it usually would return you the department ID and the sum of salaries for that ID. And so for every department, you would have a single sum. But in this case, because we're using the analytic function, we are able to display the sum for each department against an individual employee's salary. This also makes our life much easier in that because we are able to display this sum for the department and the individual salary for that employee, we are also then able to calculate the percentage of each individual employee salary relative to the department total. So Michael, who earns $13,000 and the total salary for that department is $19,000, it means he's earning 68.4% of the total salary in that department. And Pat is earning 31.6%. We can do this for each of these. Now you see Jennifer, who is the only employee in that department, earns 100% of salary within that department. And that's just by expanding our partition by clause here and adding a simple calculation, which is the salary divided by whatever result we get from this partition clause multiplied by 100. So let's turn to SQL Developer again and run these queries to see exactly what results we get. So here over in SQL Developer, we are looking at the examples of the partition clause within an over keyword. Let's back up a little and look at how it works with a regular aggregate function like the group by. We want to get the sum of salaries for our employees. In this case, we are not including a group by statement. So by default, if we run this statement, it returns a value that is the sum of salaries for all employees irrespective of their department. But if we wanted to see a breakdown of this total by department to see exactly what the total is within each department, then we'd add a group by clause to our statement and group by department ID. So if I run this, it returns each department ID and the total salary within that department. It is the same thing that you would have with the partition by clause. This is an analytic function without any partition. It just uses the over keyword, and by default, because we don't specify any partition here, it's going to use all the salaries irrespective of department. So if I run this, it returns the first name, the department ID, and the salaries for each employee, but it also returns an aggregation of the salaries for all employees put together. It doesn't matter what department they belong to. So the value is pretty constant as you change departments. But if I added a partition by department ID here, then it's going to return to me a result that is much different. So for each employee, it only returns the sum of salaries within that employee's department. So Michael, who belongs to department 20, has a total department salary of 19, which is the same as Pat, but Jennifer, who belongs to department 10, would have a total salary of 4,400 because she is the only one in that department. As we mentioned before, from this table you can see it's quite easy to calculate the percentage of salary earned by each employee relative to his department salary. And this would simply be achieved by taking the employee salary, divide it by the department total, multiplied by 100, which is what we have in our next query. We're simply taking the employee salary, divide it by whatever we have from our analytic function here. In fact, it would be nice to use the alias that we have here because this column returns the department total. But as we know it, you cannot use an alias in this syntax except you're using it in an order by clause. So we have to copy over the entire function that returns the department total and multiplying that by 100. So I just added a round here because it would give you really weird results with many decimal places. So I just rounded that to 1 decimal place. You might as well take it off. So if I run this statement, then it would return for each department and each employee the percentage of salary earned by that employee relative to the department total.